For joining me on my learning journey. Today I'm going to be sharing my learnings on how to solve problem 18 from the AMC 8 2019 question paper. I'm going to move this up a little. There we go. Let's read through our problem. So the faces of each of two fair dice are numbered 1, 2, 3, 5, 7, and 8. When the two dice are tossed, what is the probability that their sum will be an even number? So I encourage you to go ahead, take a minute, pause this video, and try the problem on your own, and then come back and hit play whenever you're ready. So I'm assuming you've given it a go. Let's get started with our problem. So if we remember, our probability of an event is the number of desired outcomes divided by the number of possible outcomes. So let's start by finding the number of desired outcomes. So what's the probability that their sum will be an even number? So that's the desired outcome that we're trying to find. So the probability of, or the amount of outcomes where their sum will be an even number. So how can we get a sum that's an even number? If you think about it, it has to be either two even numbers rolled or two odd numbers rolled, right? Because if you think about it, I'm writing it in the wrong place. Okay, 4 plus 4 is equal to 8, and 8 is an even number. 3 plus 7 is equal to 10, and that also equals an even number. But if you think of one even and one odd, like 4 plus 5, you get 9, and that's an odd number. So what we need to do is find the amount of outcomes where there is two even and two odd, and then we can add up those numbers to find the total number of desired outcomes for getting either of those. So it's this or this, if they get two even or two odd, so you would add them up. So what's the probability of getting two, or not, what's the probability, sorry. How many possible outcomes are there with two even? So for the first dice roll, if you look at it, there are 1, 2 outcomes that fit this. So it would be 2. And then for the second dice, there are also 2, because these are independent events. So there are also 2 there, and you multiply them because we're saying you have to get one of this and one of this, and for the dice rolls, you have to get both of them even. It's not this or that. So you multiply those and you get 4. So 4 is the total number of possible outcomes for getting two even. I'm going to just overwrite this in a different color so that I can keep that consistent with the second one that I'm about to do. Okay, and for the next one, what we are going to do is do the same thing, but this time for odd numbers, right? So how many odd numbers are there? How many possible ways are there to get odd numbers? And I'm going to use this light grayish color. There's 1, 3, 5, and 7. So that's 4. So you would have 4 the first time and also 4 the second time. And we would multiply that and we get 16. So 16 is the total amount for two odd. And so our statement here is that the probability that their sum will be an even number has to be equal to 16 plus 4, because that's the total amount of possibilities where they get either two even or two odd, divided by the total number of possible outcomes. And so for the total amount of possible incomes, it's really just equal to the 6 that they're able to roll the first time, and the second time they can also roll 6 different possibilities. So it would be 6 times 6, or 36. Oops. So our answer would be 16 plus 4 over 36. And this is 20 over 36, and if we simplify that, looks like we can divide both sides by 4. It would be 5 by 9, and we see that on our test. That is answer choice C. So that's it for this learning. Thank you for joining me. I'll really appreciate it if you leave your comments, feedback, and further suggestions for additional learnings below. I'll see you in the next video.